Good day everyone. My name is Jocelyn Engat and now I will discuss what is Norton theorem. What is Norton theorem? Norton theorem states that any linear circuit can be simplified to an equivalent circuit consisting of a single current source and parallel resistance that is connected to a load. Ang Norton's theorem ay parang counterpart lang din ng Thevenin's theorem kasi pwede natin ma-convert ang isang complicated linear two-terminal circuit sa isang simpleng circuit using Norton theorems. But this time, instead na open circuit voltage ang hanapin natin sa terminal na kinukonsider na circuit, this time, using Norton theorem, hahanapin naman natin yung short circuit current across dun sa terminal na kinukonsider natin. At the same time, pareho lang silang RTH equivalent resistance, yung Norton resistance, or yung equivalent resistance ng circuit across dun sa terminal na kinukonsider natin. So, somewhat related yung Thevenin sa Norton's theorem. Halimbawa, meron tayong linear two-terminal circuit. Kahit anong circuit na to, either complicated or simple circuit, tapos meron kang load na RL across, let's say, terminal AB. Therefore, pwede natin magamit ang Norton's theorem para ma-convert itong linear two-terminal circuit into equivalent a single current source IN with a resistor parallel to the current source which is the RN. Or yung Norton's resistance, itong RN. Siya yung equivalent resistance dun sa terminating theorem across dun sa terminal A and B. Therefore, ito na yung equivalent circuit natin, parang parallel resistors that have current source across them. So, kapag analyze natin yung circuit na to, pwede natin gamitin yung current divider para mahanap yung current doon sa RL. So, pag ginawa natin ito yung magiging formula. So, this is the formula. IN is equal to 1 over by RL divided by I 1 over RN plus 1 over by RL times yung current na IN. So, simply making RN over by RN plus RL times IN. Para makuha naman natin yung voltage across load, gagamitin natin na ang ohms. So, magiging formula niya is VL is equal to IL RL. Yan ang magiging formula ng voltage across dun sa load natin. So, now, we have example here. Find the voltage across and current through RL using Norton's theorem. So, meron tayong circuit dito. So, hanapin natin yung voltage across this resistor RL as well as yung current flowing through it using Norton theorem. So, ibig sabihin, hanapin natin yung equivalent Norton circuits. So, hahanapin natin yung Norton currents as well as yung Norton resistance. So, kunin muna natin yung equivalent Norton resistance. So, tatanggalin muna natin itong resistor RL. So, ngayon, tatanggalin muna natin tong RL resistor. Then, i-consider natin tong terminal A and B. So, i-consider natin itong terminal A and B kung saan nakakonect itong RL. Hanapin naman natin dito yung equivalent Norton resistance. RN. So, kapag hinanap natin yung resistor RN, ang gagawin natin is i-off natin lahat ng mga voltage and current sources. So, para dito sa 5 ampere current source, i-open lang natin. At para naman sa 10 volt source, isi-short naman natin. Isi-short natin. So, ganito ang magiging figure niya. So, kung napapansin nyo tong dalawa, floating na lang siya. Tong dalawa. So, pwede na natin siyang tanggalin. So, ang equivalent circuit na lang natira is, so, series na tong dalawa. So, makukuha na natin ang Rn. So, Rn is equal to 6 ohms. Pagplasin na lang natin siya. Plus 4 ohms. So, ang Rn natin is 10 ohms. Ito na ang Rn natin. So, ngayon, nakuha na natin ang Norton resistance. So, kuhanin naman natin yung Norton's current. So, balik tayo sa circuit problem. Okay, this time, pag kinuha naman natin yung Norton's currents, is, gagawin natin tong short circuit. Short natin tong terminal A to B. So, kukunin natin dito ang Norton's current. So, gagamitin na lang natin dito is mesh. So, we have two loops. This is current 1 and this is current 2. So, ang direction natin is clockwise. So, kung anong makukuha natin sa current 2, yun na ang equivalent dun sa current Norton's. So, dito sa mesh 1, total ang 5 ampere naman ang magsusupply ng current. So, siya na ang magiging I1 natin. I1 is 5 ampere. So, dito sa current 2, gagamit tayo ng KVL. Ipagplasin na muna natin ang 4 ohms at 6 ohms. So, magiging 10 ohms I2. Total, ang direction natin is clockwise. So, papasok siya sa negative. So, ang kuha natin is negative 10 is equal to 0. So, itong negative 10, ililipat natin sa kabila. So, 10 I2 is equal to positive 10. I-divide natin both 10. So, cancel. So, ang I2 natin is 1 ampere. So, sanabi natin kanina, kung ano ang kuha ng I2, yun din ang equivalent ng IM. So, ang IN natin is 1 ampere. So, nakuha na natin ang Norton's resistance at Norton's current. So, this time, yung equivalent circuit natin is yung nakuha nating value Norton's current, which is 1 amp. And, ang nakuha naman natin is Norton resistance is 10 ohms. So, ito ang Rn. So, ito yung IN. Okay na. Ngayon, para naman makuha natin ang voltage across and current passes through RL, ngayon, i-connect naman natin ang RL dito. So, ang RL natin kanina is 10 ohms. Ayun. So, kunin muna natin yung current passing through RL. So, let's say, this is current L. So, para makuha yan, gagamitin natin ang current divider rule. So, para makuha natin itong IL, gagamitin natin ang current divider rule. So, IL is equal to 1. Kukunin natin yung conductor no RL. So, 10 or over by 1 or over by RL plus 1 or over by Rn. So, 10. IL is equal, meron pala tayo ditong IN. Sorry, I forgot. So, pag ni-solve natin to, meron tayong 0.5 ampere. So, meron na tayong IL. Ngayon, para makuha naman natin ang voltage across RL, gagamitin na lang natin ang ohms na lang. So, meron tayong VL is equal to IL times RL. So, VL is equal to IL natin is 0.5 times RL 10. So, ang VL natin is equal to, ang makukuha natin, 0.5 times 10, ang makukuha natin ay 5 voltage. So, nakuha na natin ang IL across RL is 0.5 ampere. Then, nakuha naman natin ang voltage across RL, which is 5 voltage. So, that's all for Norton's theorem.